All right, so we've got talk from Laura, and then we're going to go into a BOF with Yvette. So without further ado, I'll welcome Laura Armstrong to the stage.
Can you all stand up?
Stole my idea, Laura.
How many of you have a data management policy at your institution? If you do not, sit down. Do not have... Sorry, research data management policy or guidance or something of that ilk at your institution, you should still be standing. Wasn't clear. And hovering between Claire doesn't work. Yeah. All right, so a few of you. Okay, sit down. Thank you. How many of you, and you can just put your hand up for this, I'm just making you walk around. How many of you would like one but don't yet have one?
I'd like a policy.
Okay. Principles is a good start. All right, so I'm going to talk about our journey to getting a research data management policy. It's not flawless. I haven't got a slide where it talks about the pain points, but I'm very happy to talk about that. Everything that we've done, we're happy to share. So where I have things online, I've put the links in the presentation. If there isn't a link, but there is a thing or a document that you think I'd like to see that, then please get in touch. So my name is Laura Armstrong. I work at the Centre for eResearch at the University of Auckland. My colleagues and I have touched on our policy or our research data management program initiatives a lot over the last few days, and there's more coming. We're really happy to share what we've learned, things that have worked, things that have been painful. I've worked at the institution for 16 years and in universities for 25. So that sort of explains, if you can see it, which I can't, so maybe you can't. I had an image of a glacier in the background, and it can feel a lot like that. Building your institution's readiness for this kind of change can take years, and it has taken us years. Back in 2016, I started working in this space, delivering research data management training, primarily to doctoral candidates. We rolled out a data publishing platform and have been developing services since. In 2020, before the thing that happened in 2020, we had our Office of Research Strategy and Integrity write a paper to get senior management to say, yes, we should have a look at research data management. We should do a stock take before we figure out what kind of investments we should make. So, a colleague of mine, Brian Flaherty, who's now retired, and I went round and interviewed a bunch of people at our institution, surveyed even more of them. And the thing that we heard is that they lacked direction. They didn't know what was expected of them. They didn't know the services that were available to them, and they didn't necessarily know how to use them or access what was available. We developed along the way a capability maturity model that's very specific to our institution. We published it so anybody can use it, and I think David has. Yes, he's nodding. As I say, it's very specific to our institution. It's very detailed, so this is just the first page. I don't expect you to read it. It's across 6 dimensions, 5 levels, very similar to other people's capability maturity models in this space. We added the dimension of Māori data sovereignty. We engaged with Maui Hudson to give us a bit of a review on that. This is the first page. There are 6 more pages where each of those dimensions go into much more detail. Within those 2 things, so bringing together the capability maturity model and our stock take report, we developed 20 recommendations, 19 of which were accepted, one of which, too expensive, too hard, put it down. But that's not what we're talking about. Our second recommendation was to develop a research data management policy. So that's the recommendation. ORSI is our Office of Research Strategy and Integrity, headed up by the director of that, but then they report to our Deputy Vice-Chancellor Research. These people headed up a working group to develop this policy. I was on that working group, but it was led by them. We initially figured out what's important to our institution. So we've talked a lot, people have mentioned a lot about fair, care, Māori data sovereignty. Those were things we wanted to incorporate into the policy to enable our institution. Specifically, the University of Auckland has a strategic document that says that we will progress towards becoming a Māori data sovereignty organisation. We have a position in place within our university that was created out of this stocktake that supports that, but we wanted that to be embedded in our reasoning and in the language of the policy. We obviously needed the policy to support and enable our researchers to adhere, to comply with requirements from funders, whether they be international or national. At the same time that we were developing our policy, unbeknownst to us, MB were developing what was to be called their open research policy, and we had calls in between as we were developing ours and they were developing theirs, so we were mostly singing from the same hymn sheet, which was great. We also did a kind of horizon scan, so we found 4 other policies internationally that we thought we could learn from. We didn't pick them because of the institutions they were from, we picked them because of the maturity of them. They'd had them for 10 years or so, or it was their second iteration. And we used those specifically, and a colleague of mine did their review, for the structure of our policy. What worked in other institutions might work for ours. So we took on a structure that took the kind of life cycle approach. So if you're starting a project, what is the first clause of a policy that you might need to consider, and working your way through as you go through a project. We thought that was logical. We also leaned on the ARDC's underpinnings work and their recommendations about policies and procedures. And we were fortunate within our institution that our policy process was quite mature. So we had a lady in the policy hub who said we couldn't use the word should or shouldn't. So the language became really important. It was a thou must or don't say it. The process was that the working group developed a draft based on that. We had that floated to our university executive committee, so senior leadership had to buy into, yes, we were developing a policy, yes, you know what we're going to make your researchers do, are you okay with that? And they were. So that went into a consultation process where we posted it publicly, because that's what we do with policy development. I'm not sure that the public ever comment, but they could. And researchers gave their feedback. Do like that, don't like that, it's not strong enough there, what on earth does that mean? I hope you're going to have guidance, etc. After that consultation and some tweaking, we went back to our research committee, which is our Faculty and Large-Scale Research Institute Associate Deans of Research across the university, and said, do you approve? They said yes, but there's a plus there. We had a change of DVCR at that point. So we went and had a chat with that person, and we had one significant clause change, which I'll get to. Then it goes to Senate, and the VC stamps it, VC stamps it, and it goes online for public consumption, but it's not effective yet. So, during that process, which took months, the university also engaged in developing a data classification. We already had a data classification for administrative data, so we had a data governance group, classification, all sorts of paraphernalia around that, but it was just administrative data, data that the university knew about itself. As that was reviewed, we managed to lobby to put research data in there as well, and then they thought, in for a penny, and they added teaching and education data. So we then had a data governance and data classification across all data types at our institution. And in this context, that institution is the University of Auckland and Uniservices, who up until then had different ways of classifying research data, different terminology. We borrowed from digital government. They have a much longer than 4, but they go into confidential, super squirrel, don't tell anybody it's happening, which we tend not to have. We end up with public instead of their unclassified, internal instead of classified, but then sensitive and restricted are exactly lifted out of their definition. I've given the definition here because sensitive, as we've discussed, and David's not here now, sensitive means different things to different people. When we teach research data management, we talk about how sensitive things can be. You might be sensitive to a thing when somebody else is not. You might become sensitive to a thing when it wasn't designed to be. And my colleague, Matt, where are you, gave me a great example of data becoming sensitive when you're doing animal traps in a park in Wellington, and then you captured 2-legged animals doing stuff in the bushes. It becomes sensitive. So that's our definition of sensitive. The relationship with ethics is tricky, and it became trickier as we rolled out the policy. So defining things as sensitive because they're going through an ethics process is a little confusing sometimes. So this is our policy. It's for all research staff and students undertaking research. So it's not, you could be an undergraduate undertaking research and this still applies to you. It's owned by our DVCR, managed by the director of ALSI, so senior leadership fully engaged. It became effective 3 months after its rubber stamping on the 1st of July. I get asked a lot, is it retroactive? And the answer is no, because that's far too hard. But for any projects that were starting after the 1st of July or were applying for ethics after the 1st of July, this applied. A 3-month lead-in from yes, this has been approved to go live is hideous. I wouldn't recommend it. I think the NIH gave something like 2 years of warning, by the way, we're going to be requiring. I'm not saying that we should have been that slow, but 3 months was hard. We developed a lot of resources around this. So that's the first page. Gets an indication of the purpose. That's where we have embedded the FAIR, CARE, Māori data sovereignty, and even Pacific data sovereignty. Thank you. We divided into university responsibilities and then research responsibilities. One of the things that one of my colleagues pointed out to me was, those are a lot longer. And they are, but they are much more detailed. If you look at the universities ones, they're massive, but there's only 3 of them. Not going to go into detail about these. Happy to field questions. The bits that were new were 7, requiring a data sharing, data transfer, some other kind of contractual relationship document if you were going to be sharing or transferring data. That was new and is new to a lot of researchers. Created quite a lot of heated debate. Hey, Sarah, she's not here. Yeah. This is what the guidance document looks like. So we have a research hub at our institution. We created topic by topic guidance so that you can go through. On here, I've clicked 9, and then there's text about what do I actually do to achieve this clause? Where are the services that I might want to use? Where's the help that I might need to seek? Where is the example of what that looks like in action? When we go out and teach it, we talk about the clauses clause by clause. Here's the stuff, this is what we mean, what that means for you, whether you're a supervisor, doctoral candidate, a PI, whatever that is. One of the big things that you'll have heard us talk about if you were paying attention in other sessions, is that we've also moved the institution to thinking about research data and research data projects and storage particularly as a project by project unit, which has been tricky, frustrating for people because they either thought of themselves as, well, it's my research, can I just put all of my stuff there? Or they thought of it as a lab, can I have everything there? Or they thought of it as, we do fetal physiology, can we just put all of the fetal physiology in one place? From a security, from a governance, from an ethics point of view, we've had to educate people into why defining them as projects is helpful. And we spent a long time engaging with researchers, both through the Research Hub, creating resources, changing our workshop content so that it's very embedded and structured around the policy and walking people through what's required of them. Talking to our research committee, so that's the Associate Deans of Research, to say, as we go to each of the faculties or schools, what would work better as we communicate to those communities? Because they're different. Their understanding of data, what is data, what should I do with it, what on earth is a data management plan anyway, is very different. We continue to do that, given ourselves a little hiatus and them a little hiatus over the Christmas break, but we are about to, as we get back next week, launch back into another round of different faculties talking about how does this work for you, what does it mean, what are your pain points, and as we have other programs coming online with the data management planning tool, which we hope to have, do we need to collect exemplars of data management plans from our different research communities to share those?
No wonder you didn't give me a look when I told you you had 2 minutes left. Very well done. All right, straight away.
Quick question, how much has actually changed on the ground?
I have no idea, Martin. One of the things, for example, the data sharing agreements was thoroughly new. That doesn't mean that they weren't happening before, but it wasn't a policy requirement around research data. They tended to happen if there was a contract requirement and at that contracting process. I asked the people who deliver those support for agreements, how many of you had? And they said a number that was less than the same last year. That's complicated though, because that whole team is now moving to a different part of the university, so there were some structural issues that are being addressed, nothing to do with the policy. I think they're also interested in metrics, so we have another project which Yvette could speak to, possibly, around persistent identifiers. So can we track how much of our work is being published compared to what is being stored quietly under somebody's mattress? Those sorts of things will be evolving. But at the moment, we're at the do you know what's expected of you before we measure are you doing it?
All right, more questions?
Just wondering if you had some kind of cycle embedded. For example, you're asking your researchers to store their data in a university system, but they don't like that system and they want a different one. Is there some sort of cycle whereby you can include or modify, sort of adapt to your researchers?
Outside of the policy work, which is obviously we're helping to communicate and educate about, it's not our policy, so not the Centre for eResearch. Centre for eResearch does provide a lot of that storage. When people want to use, so when people come to our door to say, I've seen the policy, can I have? We offer them options, so hopefully they pick one of those options. If one of those options is not appropriate, and sometimes they'll have good reasons to do that. For example, we had a project that were using a externally hosted SharePoint site. Using SharePoint wasn't the problem, it was the fact that it was externally hosted. We're in the process of bringing that back into the institution, and they will get an exemption or authority to operate research data in that different to normal or different to standard storage environment. So there are ways to do it. We're not saying thou must pick A or B. As we go out and talk about storage, people always want something special and different. It's very difficult to scale, very difficult to sustain from a price point of view, as Wallace will tell you. Yeah. Don't know whether that answers the question.
So can you share more details about the governance leadership process you followed in order to ensure you will have the champion and the support for the process you followed?
So the working group was chaired by the Associate Director for Nick. What's Nick's job title? He's Associate Director within the Office of Research, Strategy and Integrity. I've forgotten his exact job title. He did most of that legwork with our senior leadership, so that's the university executive team, so that layer. We did the ADRs, so that's the Associate Dean's Research, that's the next layer down within each of the faculties. Mark attended the Senate meeting where it was discussed very quickly, as I understand it. So that's the University Senate. We didn't get a huge amount of feedback through the consultation, so one could see that as they all loved it, or that people don't really involve themselves in feedback consultation processes. Either way, when we went out to talk to departments, there was quite a lot of, well, this is new, what's this? Department by department. It's intensive.
So my question's kind of related to that. Change management process around this. You know, if you look at change, the key question is what's in it for me?
Yep.
So what was your what's in it for them? How did you pitch it to them that actually, or was it more of the, well, you're going to do this because it's policy and...
No, because it's not my policy. There's a, when I say my policy, it's I'm not the person holding the stick. I am the person communicating that this is a thing, and by the way, I'm from a department or a centre that can provide services to support it. So there's one bit removed from that. Easier for me, but also easier for the institution to do it that way because it's a slightly softer approach. I know from other circumstances, researchers in faculties don't necessarily like the centre telling them what to do. So we were mindful of that. And it's not thou must, although the policy is written like that. It's how can we help you do something that is better, that your funder, that your participants, that is going to be more secure, is going to be more reproducible, is going to make sense when somebody comes to apply some governance to this in 5, 10 years, when you're dead, whenever.
Pretty much the same as what we've been saying forever. It's just that there's policy.
A little bit of both. Some of it is, lots of you are already doing it. Great. We've just codified it. Some of you, this is utterly new. Can we help you?
I think we might draw it to a close there, but some of these issues may pop back up in the BOF, I suspect, anyway. So let's thank Laura.
Kia ora, welcome to the last part of the afternoon. Not the last BOF though. This is a warm-up for the next BOF. We wanted to have a chat with everyone around thinking about secure research and managing your sensitive data. Now we had a birds of a feather. We had a conversation earlier in the week. We were really looking at the co-design that we went through and the different policies and processes around sensitive data. What we wanted to focus on now in this birds of a feather, thinking about the different architectural designs that we've put in place for sensitive data And it's not just going to be me standing up here, it's going to be a few of us talking. So a little bit of a welcome from me. I was going to give you some international context, but I actually think over this week we've heard some really great presentations around sensitive data, and Carol's talk about all of the different things that are happening across Europe and the UK. So I'm hoping most of you heard all of those and we can kind of move towards the conversation. But I am going to, a bit like Laura, make us all do something, because I know sitting in the chairs, my bum gets a bit numb. So again, can you stand up just to get some blood flowing in our legs? And I was making this up on the fly because I wanted to get some paper out and make you throw it at each other, but then I thought it might take too long. So now that you've standed up, jiggle out a bit, put your hands up, shake it out, turn to your neighbour and just talk to them, say something. What is the biggest thing in sensitive data and secure research that is on your mind? So I'll let you all sit down. So what we're going to have now is a few short presentations. We're going to take you through, Michael's going to take you through some things around security. Jun's going to say some things from a NESI perspective, and then, he's laughing, he's going to say some things. And then Andre and Martin are going to take you through some of the implementations we've been doing for the Secure Research Environment Initiative. So I'm going to hand over to Michael.
We're here to talk. I'm just an enabler. I don't need any more applause. Kia ora. My name is Michael Carrick. This is a lot about me. That's not what's important. But what I want to do is set some questions for the stage around having this conversation. It's about making those connections and understanding the why, the what, and the how. It's really simple topics, but we want to protect. From my perspective, as a security-oriented individual who wants to enable research, we need to protect all these aspects. Participants, the researchers, the IP that gets created, university and CRI brands, competitive advantage, and what's becoming now more to the forefront, national security. There are nation-state actors that are after everything that we're doing, and they're coming up with some really creative ways on how they're going to try and get it, which is really confusing and not well understood by researchers or staff. So a couple of the questions that I want to understand, and maybe is a good feedback point, what is the primary driver for securing research data at your institution? Which one of these plays in there? And then I'm sure it's a combination, but what's the next one after that? How far beneath it is it? Is it right behind it? Are they 50-50? Is it a 60-20-10 and then some other 10% split? I need to do some math. And then who is setting that priority? Auckland, it was a combination effort between our Office of Research, our Center for eResearch. Does that need it? Should it be driven by IT somewhere? Wallace, you need more work, so can you drive it at Otago? But who else needs to set that priority and set that vision? And then the what. So we protect data, infrastructure, people, and the processes, because those nation-state actors are attacking all of those. It's not just coming in over the wire anymore. And so how are you going to approach protecting your data? You can't just say, I've got a firewall, I've got patching, I train my folks. That's not going to protect it enough. How do you adapt and refine your researchers to understand that there is a way to collaborate and have a limited pool of trust for those that don't deserve it, that are just going to take your data and further somebody else? And then how? An SRE, a TRE, is that just the fix? Yeah, we got one, data's safe, walk away. How do you communicate it? How do you tell 4 years of a policy effort to your researchers, to the community, to your executives? How do you do that? And then how do you govern it? How do you know how effective it is? How do you know how much of your data has been protected? How much is it still at risk? And then, so a lot of that, how do you sustain it? Laura was talking about, yeah, we can do exceptions, but that doesn't scale. We can't give everybody an exception because then we can't govern it. We also can't say you must use A or else we can't conduct research. So those are my questions. I wanted to seed some of those thoughts to get you guys thinking about for the BOF so we can have a good discussion, because it's not just us, it's not just the rest of the presenters, it's everybody out there. So I'm going to hand it over to June. He is next, right?
Hi, I'm Jun from NESI. I wrote Claire's name down as well because she kind of leads the project now, but I did more architecture work, sir. But I'll be talking both architecture and practice because it is very hard to separate those two in this project in particular. So this is our involvement in Rakaora Pathfinder project, building a prototype with a walled garden to enable research for Maori health and genomic data. So Rakaora program was built on top of over a decade of trust and relationship with participating Maori community for the primary care, Ngāti Poro Oranga, and also the governance group for Auckland's tertiary care, Iratatai Whakaeke. And as NESI joined the project much later on top of the built-up relationship, we were reminded to take the relationship-first approach, and here are some of the tikanga attributes designed by the Maori leadership group and really help guide us to understand the values, and what we built, the architecture is only a small representation of these underlying values. And we had regular co-design rituals where we were able to learn and share the understanding of community needs and values and meet with various technical options. Can I go like 5 minutes? Yeah, so here's a quick perspective of what the researcher might go through. They browse available metadata, apply for access, and do research, but this is very simplified, but what they would do is actually submit a workflow into the walled garden environment, so they don't actually get to see the actual data, but only the resulting output of the workflow, which is also something that has to be approved and validated. And from the perspective of the kaitiaki, they would review every application and also have visibility to all the research outputs. And we have an audit system that shows all the information around what's been done and when and by whom. So we used various open source technologies and GA4GH, Global Alliance for Genomic Health standard for passport and visa to handle permissions. And we used HTS-GET for data retrieval, which enabled us to retrieve only the needed parts of the genome data. And in particular, I wanted to show you REMS, REMS system stands for Resource Entitlement Management System, built in CSC Finland. And this is an open source project as well, which handles processes and consent for various genomic data. What it does well is it gives flexibility on defining the levels of consent that can be given, and consent can be withdrawn anytime, and you could assign different kaitiaki for different groups of data and customizable forms and all that. What's really important here is that the understanding that each Maori or Pacifica community we engage with, they might have different expectations, requirements, so that flexibility was really important, and also all of the needs and things that might change over time, even with the existing relationships. You can read more about the context from the website. The link is very hard to follow, but if you Google Rakaora, should be the first result. Yep, thank you.
So, hi all, I'm Andre from Auckland University, and we've been building 2 pilot programs for a trusted research environment or a secure research environment. Me, Clem, and Reese from AWS have been working on the AWS cloud version, and we've also got Martin, who'll give a talk after me, who, with a bunch of the other folk, we're working on the on-prem solution, which is a Nectar, which is a OpenStack solution, but inside our data center. And we've kind of settled on some naming schemes where we just like internally have started calling the AWS version the TRE and the on-prem one the SRE, so those terms come up a bunch. This was not just an excuse for me to mess around with Markdown to generate flowcharts. But it's kind of sort of our workflow at the moment for the AWS version. So what we do is we have a bunch of separate roles that do different things, and at the moment, data is ingressed via admins, which is obviously not ideal in the long term. People should be able to ingress their own data, but we can't do that at the moment. And that goes into a data lake, which in this case is just an S3 bucket that's encrypted at rest. And then from that point, users with both the data governance and the researcher role are able to spin up workbenches, and workbenches are just virtual desktops. Usually Windows desktops. We can do Linux terminals, but it's a bit of a gross process. I can talk about that later. It's unfortunately not a great Linux experience at the moment. And they can do some work in, say, RStudio or Jupyter or whatever they want. Well, not quite. We've had some issues with licensed software, so things like MATLAB and things like that. Touching licensed servers inside a lockdown environment has been an issue. So users do some work, and then they submit an egress request, and that goes back into the data lake. And then admins, well, not admins, sorry, data governance folk get an email that there's some data to egress. They can look at our egress app and see what data's there, and they can spin up their own workbenches to check it over, to just make sure that someone has, the graphs don't have any information that's not going to be safe, or that all the personally identifiable data has been removed, and then they can export it. That has not come through very well. Sorry about that. So I guess some of the things I think our platform, or the platform we've been working on, helps with is collaborating, right? So I think that's one big thing is, if you're working with some sensitive data and you've got to collaborate with different people, I think that's something it can help with. It gives you access control with granular control of the data, even within a project. So, some postdoc might see one thing and a PhD student might see another. And then audit trails is, logging and tracking. And even if something goes wrong, at least in theory, there should be a trail of what it does. But one question I sort of had for you all was what we don't help against really. And if someone's a malicious user of the system, like one of your participants in your study or something has access to it, they can take screenshots. We can't stop people. It's in their own homes, right? It's not, I'll talk about it in the next slide, it's not the stats IDI. We can't, we're not in a locked room. And also like really large hostile entities who are very, very focused, we're not going to be able to stop them, I don't think, right? Maybe it's annoying, but I don't think we can totally stop them. So my kind of question that I was kind of interested in posing was, how do we talk to our users about that in a way that doesn't make the users who are a little bit less technically comfortable, like just freak out? Well, if the CIA can get it, or the FSB or something, then what's even the point, But it does solve the problem of leaving a laptop on a bus. But we're in that space, and how do we communicate that well? And obviously, hopefully more than just leaving a laptop on a bus. But yeah, so how do we communicate that well without stressing them out or making them not want to use it? But now I'll pass on to Martin, who's going to talk about the on-prem.
Hello, my name is Martin. I work at the Center for eResearch with Andre and Yvette. I should say this is not just my work, so my colleague Rob and also Andre, and there were a lot of other people involved in the discussions, and I'm just presenting this here. I remember when we started this secure research environment work, I was often reminded of like an Indian parable or folk story, and maybe because I just came back from a Sri Lanka trip, I thought it would be a nice idea to scheme this with this, and if the talk is too boring, we at least get a story out of it. So I remember when we started, or maybe a show of hands, who here has worked with a secure research environment? Okay, so very few, and this is exactly the situation we were in. So we had the task or job to figure out how could we implement something locally on premises in addition to a cloud-based solution. And we thought, actually, we don't know. And so we had a lot of discussions, and we realized people were looking at an SRE from all kinds of different angles. And I often thought, what do you mean? This is not what an SRE is, and should this be in scope? And likewise, my colleagues thought similarly. But over time, then our thoughts matured a little bit. We talked, what was very helpful to colleagues from Monash, who were by then operating a SERP environment, I think, for 2 years. And they took the time to take us through, we had 2 video calls with them, 1 hour each. One was with a more user angle, like how does it feel for researchers to use such a platform? And then we had another talk to them about how do you operate that? What are the components? How is it wired together? And that looked great. We thought, let's do that. But then it was too expensive. So we couldn't do that in Auckland. And so we continued implementing or developing our ideas. And then we learned that the Nectar colleagues from QSIF were actually working on a similar solution for the same reason. I think they had planned to use SERP, but SERP was just not feasible for them either. So they developed their own solution called Keypoint. We had a chat with them, and then turned out a lot of ideas were very similar. We also talked to colleagues in King's College in London who also built on very similar components. They were a little bit more open when it comes to less restrictive than the QSIF colleagues. We also talked to AWS about their options, and we had a look at the TRE blueprints from the Alan Turing Institute, and we talked to our researchers. And so over time, we got a much better idea. And despite there being still different views on architecture and level of restrictiveness, turned out there's a lot of patterns or components that are the same across all these systems. So that is secure data storage, of course. There's virtual machines that have access to that storage. It's the way for researchers to work on the data that they have in their environment. The whole system is essentially accessible through one central web-based access portal or dashboard. There's very tight access controls. There's controlled processes for data, to getting data into that environment and to get data out. People have different roles in that environment. Like you can be a normal researcher who can work on the data. You can be a data custodian who's responsible for managing access and managing the data. There's ingress and egress approvers. Depending on the size of the project, you need these roles. But it can also be that you have a one-man project and you have all of these roles. It's important to have an audit trail, and ideally this, that environment is set up in an automated way. Like you shouldn't have too many manual steps. That's for reproducibility and for guarantee of the process. So very briefly, I know this is probably hard to read, but this is really what we ended up with. So we have a bunch of shared services which are used by all SRE implementations, or instantiations, I should say. We use a bunch of a few university-wide services. And then we have services that are unique to every project, which is an SRE. And along the way, we came across a lot of decisions and challenges, and here are just a few that I want to point out, where we had differences, for example, with QSIF. What QSIF does is that every SRE has, for each of these services here, in a cookie cutter style, they set up, for every project, they have a database, a message broker, an Active Directory, and all these things separate. What we ended up with, just for operational maintainability, and also after talking to security, they said, well, whatever you can share should probably be shared. Because if you end up with 100 databases and 100 access portals, at what point does that become maybe a little bit unwieldy to maintain and to operate? Another important decision was identity management. In Auckland at the moment, people log in with their institutional credentials. And one important criteria for researchers was that they said, okay, we don't want to log in 3 times, like 1 time through the access portal. And then when we log into a virtual machine, we need to authenticate again. So the way we model that at the moment, that's similar to how QSIF does it, is that as soon as you are logged into the access portal, you have an internal identity, which is not an institutional identity, but just limited to this SRE environment. And that allows sort of like a seamless login from the access portal to a VM. Is this a good decision? Security thought yes, but I'd be very interested to hear what other people think. One thing that we are still struggling with is licensing, because the systems sit in isolated networks and don't have access to university resources by default, and not to the internet. Like how do you manage licensed software? Like, do we contact license servers at the institution, or should we have an SRE-wide license server to manage things? Not sure. And the other decision is like, how locked down and restrictive do you want to be in an SRE? I found that quite interesting, the difference between QSIF and the King's College. And that QSIF said, you have to stage data in, and you have to go through a vetting process by a data custodian of a project. Same for data out. The King's College folks found that too restrictive. So they said data stage in is quite flexible. So they can, researchers who use an SRE can stage in data from a faculty drive, for example, at the institution. So they don't want to be restrictive too much on that level. For them, it was more important that whatever comes out of an SRE needs to be really, really carefully vetted. And would be nice if you have opinions about that or experience. And that was all I had. Thank you.
So this is really where we all get to have a discussion, and all of the points that we've raised, any that you have that you were talking about loudly at the beginning, now is the time for us to share those. So I think I took a few notes from what everyone was saying. Put my glasses on, getting too old to see without them. Who is setting your vision? That was something that came up. So how many of you have a desire, a vision, are somewhere on the journey of thinking about, yes, we have sensitive data, we need to have the right secure environments? Now, you might be right at the beginning, you might be somewhere like us along that journey. Okay, a fairly good number. Does anyone want to make a comment about who's really driving that, or if there's people driving it? You've heard from us around, we had a policy, we had initiatives, so we've got support, we've got buy-in from a bunch of our researchers who know they need it. What's it like at other institutes?
So I'm François from the University of Canterbury, and I guess we have some directive from the University Council that everything needs to be secure, but really when it comes to secure research, I guess it comes from some of our researchers. I'm thinking of one researcher in particular who need to have data from the National Institute of Health in the United States. And as you may know already, they know don't trust the researcher anymore. It has to be, they have to have sign-off from a data officer in the institution. And we have to prove that the data is secure.
So that's really interesting. Like, we have definitely had the NIH conversations begin at our institute as well. I think there's something interesting in there from all of us to think about what patterns can we share, which I think comes to some of the latter questions around our infrastructure and what are some good practices that we could all say, hey, we've done this to our infrastructure and this works, and it, you know, we can say that it meets security XYZ standard, which helps us with the different grant funding officers. Do you want to comment on that at all, Michael? From a security frameworks perspective?
I was going to be a mic runner, but yeah, it's I'm probably loud enough without it. It's that American in me. So I think there is a lot we can share. We learned a lot going through it at Auckland. It was a lot of, well, why are they going to want to look into my data? Like, it's my data. Are they going to want to look into all this other stuff? So there's a lot of that crosstalk. So I think there is opportunity there to have conversations around how to respond to these international organizations of saying, we're changing how we're doing things. Get in line or don't get our money. So there's a lot of opportunity to share those learnings. It is a challenge when the NIH says everybody has to do this at the same time. There's not, oh, well, we can tackle it and then share. We all have to kind of tackle it at the same time. But maybe there are some mechanisms there to share that.
How about the patterns of logging or the patterns of identity management? What do people think about the identity management side of things? Is anyone doing anything in that space? Does anyone want to ask a question?
I also don't really need the mic, but yeah, one of the things I find promising are the sort of more universal identifiers like ORCID, potentially for linking things together, partly just because I think the number of projects I've seen that will start with some view on identity management and then we'll discover they need to change the view on identity management or realize that that platform gets used for a center of excellence that's outside the organization as well as inside it. It's really nice when there can be some good mapping to the individuals as opposed to identifiers of where that individual happens to fit in some organization at some point in time. But certainly in investigation, this wasn't solving the problem very much, but I was interested in the attribute management of ORCID and tripped over some extreme weirdness in terms of the level of assurance that you could have about the security of those attributes that meant that it actually wasn't a solution at the time when I was first looking at doing something small with that, which I found quite surprising. But the idea of at least having the identifiers that work for the people rather than the staff member, I think is a useful thing to kind of keep in view. It's not front and center for this technology though.
Some of the thoughts I have from an identity point of view, and particularly with people, is research isn't just me at my institute. So it's usually me at my institute with other people at other institutes. So a traditional way we have got around that in most universities is people have sort of collaborator status, shall we call it, where they get an institutional login. So that idea of having an identity that's trusted and verified, and then having virtual collaborative groups. If Vlad was in the room, and I don't think he is, he could probably give us an update on the sort of work they're doing in the eResearch type space around virtual communities. But that's something I think is really interesting. How do we work together to design systems that can talk in a trusted way for our collaborative research groups? Is that something other people also is on their mind?
Well, now that he said it, yeah, Tuakiri on the EduGain, all those. But ORCID would be nice, actually. I thought first when he says that, but you don't have a password. But yes, you do. But that escapes the control of the institution.
Thanks, Francois. So when listening to institutions that are trying to set up these TREs and the use cases they're coming up with, it's really varied and very, very varied what they want in the way of users that get access. And in Australia, we have the AAF as the organisation, and we talk very easily about, oh, AAF credentials, but that's generally just the staff that are directly employed at universities. So then you have the collaborators, but where do collaborators stop and start? And how much trust do you give to each of those collaborators? And are they, sometimes they're people from industry, yeah, sure, but you're also getting to the point where we're talking about people from community and community groups that want to have a say or a stake in data, and should they be given access? What sort of level of access there? So I think that's one area where it starts to get more complicated. Another area is how do you administer that? Where do you administer that? And that's one of the projects that the AAF, the Australian Access Federation, is starting to set up some sort of virtual homes where you can define which groups of collaborators are going to be on which project and which roles will they have in that space. So there's some stuff happening in that space, but it's still very much evolving.
Mark.
Thanks, Yvette. And as a follow-up to that, I think that was a really well-made point. As a follow-up to that, I think one of the things we've learned is that for a largish university, we might need to support 100 or 200 of these separately because we have a lot of clinical and personally identified research going on. So not only do we have to be able to scale, but we also need to be flexible because each of those will have its own unique characteristics. Each of them will have its own governance requirements, and the standards that they're applying might be defined by a different funding body or a different professional body or a different classification of data in the university. All of that means that we need really flexible interfaces that allow communities to essentially describe their own governance. If we have to build a bespoke governance model for each community, we're dead. We have to be able to allow that community to express their own governance, who has access to what, for how long, and how do you get stuff in and how do you get stuff out. That has to be given to the community or we're just going to die.
And yet we need to do it in a standardised IT environment we can manage easily. Does anyone else have a question that they wanted to pose? Here you go, Reese.
Probably following up from Keith. So I was thinking, working in the biocommons, we've gone UX driven. It's very frustrating. What are the actual models of use you're trying to support? And the other thing I remember is a long time ago working with industry and research, industry would say, why do you guys want to think about problems we can't solve rather than problems we can solve, and particularly problems we can solve right now? So why don't we think about the use cases? There's a really simple one, isn't there? I've got some data and I want to control other people's access to it. We can probably do that. There's 300 of these environments and we want to cooperate across all of them. That's step 10. And why don't we set out, say, what's the personas and what's the use cases and which ones do we actually know how to do, and let's agree how to do them. And which ones are going to take 10 years like Carol, and we're not going to solve this year or next year, and there's no point promising them to researchers this year or next year. Why don't we do that? Anyway, that's what I was thinking.
I was just thinking about Mark's commentary about death, and I think it's metaphoric, but it does raise the question: what's being secured against, what's being protected against, and you can kind of take that as a given. But I think Michael mentioned, there are all these different types of malicious actors, poorly educated PhD students, state-sponsored hackers. Depending on how you address that question and what an institution's tolerance is for some kind of breach or problem, it does help, I think, shape the solution space. So one of the things I saw, which I think is really essential and gets overlooked often, is an audit trail. So having the provenance and sort of a history of how these things have been treated and the efforts that have been made to protect data would be a protection against, say, reputational damage, in my view, because this happened, it's a story in the news, but the institution can say, yes, but we did everything we could, or these are the things that were practical to do to help mitigate that. And it's very hard to engineer a system which totally takes out any bad actor or even benign sort of incompetence. But there's a certain amount of what is the, and maybe it comes back to what's secure and what's trusted and what's sensitive. Everyone has different views on this. I think it was really interesting to see that in Auckland there's been a shared sort of taxonomy between uni services and the institution, because IP is another one. We want to protect our intellectual property, so there's a real commercial stake. But I think it's easy to overlook what's been protected against, and maybe in a way that's death is a good thing to sort of protect against it. But maybe there are other things to sort of factor in when we think about this.
Yes, I think death's good as well. Following on slightly laterally with that point about the contrasting approaches to security, it's been well explored the ways that you can try to deal with But you run into the digital rights management version of how you deal with the case of someone taking screen recordings of a secure environment or something like that, which was mentioned earlier. What's interesting that I think should hopefully be a boost that's coming partly because of all of the AI stuff and generative AI and shifts in some of the media and fake news, the provenance push has been very, very strong for looking at watermarking and having different ways of describing provenance metadata through artifacts. So I think actually that's going to be an area where, you know, in my mind, there are some parts of this picture that compartmentalize quite cleanly, and I think actually some of the provenance work, I think there's a long way we can come with that, but there's actually a number of really, really useful initiatives that are shifting forward quite quickly now, along with AI, that are trying to actually boost that sort of provenance record. So as the kind of post hoc defense against having tried to do your best and having had actors still actually do something malicious against you, I think that at least for some types of data, we're going to see a shift in terms of how much easier it becomes to engineer some of that provenance tracking, which is definitely good.
Yeah, so building on a couple of those ideas in like how you have that conversation around how you protect it, you have to understand why and what is driving that, and you have to have all of those conversations at the same time. Because you never know when NIH or NHS or MIMBY or the Australian Defence Force is going to change what they're going to require you to do. And so it builds on a lot of that where we have to do this in a repeated way. And so it's really difficult to have the 17 different conversations that need to happen at the same time unless you have a clear driving team that's going to interact with all the different moving parts of this to keep moving forward.
I know in the past when I've worked with personally identified data, I've often wished that I couldn't see any personal identification. So I was really taken with the idea that Carol mentioned in her talk about the open safely technology, and that's fairly new to me. I wonder if anyone else has experience with it or thinks it might fit. Because if I could have a system where I can't see the data but my program can, I'd be feeling more comfortable. Has anyone used that?
Reese.
So in the detection of child pornography, they have to train AI systems on training sets, but they don't want their staff to see it. It's a very big problem. So there's a centre at the University of Monash who's trying to solve that problem. So yes, it does happen.
Anyone who hasn't looked up Open Safely, it's a really neat little bit of technology where you can access a system without seeing the code, with code without seeing the data itself. And I think it also creates synthetic versions so you can play with it, work with your code, make sure it works, and then put it into the actual system. So
if I can make a comment, the most amazing thing I've ever heard of in de-identification was from the Australian Bureau of Statistics. What they do is they add jitter to the data they give you. So they add errors so that it's de-identified in a way that won't disturb the statistics you're going to do, which I find amazing.
How do they test that?
I know, I couldn't believe it.
I think it's one of the, if you look at the de-identification processes and techniques, it's on the list of techniques. I'm not an expert in it, so. I think we've got till past, so I think we've got a little bit more time. I'm going to pose a question while walking the mic around. What about our users? So how do we help them? And, you know, a lot of the stuff we talked about in training space, but how do we make them feel comfortable about the environment, that it can do the things they trust us that it can do without freaking them out? So we'll come back to that.
Thanks for saying come back to that, because I was going to make some completely cyber security theory geeky point that has nothing to do with users whatsoever, but does have to do with the differential privacy and the k-anonymity and techniques like that. One of the things which I think is potentially an interesting new risk is that some of those technologies are designed to protect records in a set. But there is, I believe, a shift now that there's a different type of attack that they don't protect so well from. If you shift to actually looking at statistical attacks, so you're not actually trying to find an individual, but you're trying to find an individual with a certain probability, some of those de-identification techniques actually collapse really badly. So we could be in a space where there's a little bit more of the sort of experts doing cybersecurity research having to do more work on this, because I think, again, there's sort of different levels of, it's the same sort of questions, but at the very low level, what are we actually trying to protect against? What's the threat model in terms of what the statistical data change is actually protecting against? But yeah, let's talk about users.
Katie, coming.
Going to go left field or somewhere else, because this is pretty much all about personally sensitive data, and you're all assuming here that your researchers or your other organisations within your institutions are telling you that this is the type of data it is. But what if you don't know that it's personally sensitive data and it's on your systems? Or what if you are managing storage infrastructure or other types of infrastructure and nobody is telling you if it is indigenous or commercially confidential, and you don't know any of that? How do you people tell you that stuff when you're on the infrastructure side?
That's where we are now, isn't it?
Good luck finding out.
Yeah, like I say, that's where we are now. We have all that data and it's not properly tagged anyway. So we're just on the journey of providing something which will need cataloging at some point.
I think, oh, Laura has something to say. I'll give you the mic, Laura.
So just on that, going back to what I said about the policy, it's not retroactive. And Reese's point about doing what's achievable first, I would suggest that you start with projects that are starting and they want to tell you, we're going to be collecting X, Y, Z. And then you need a DMP from people. And then you use that, ideally in a programmatic way, to funnel, well, that can go there and that can go there and that can't go there.
I think there's some interesting things in the classification we saw, or the taxonomy of the way we can classify data, where if we can help people be better at that, so that we have the information and then we can direct them to the correct systems for that type of information. We might not get it all the time, but we should at least move the sort of lever in the right sort of direction. So I think there's something in thinking forwards where we want it to be and how we want it to work, and building it incrementally as we go in that respect. And I think that also builds trust with the users, which I think helps with them going, actually, you've told me this system's fine, you're doing all the right things, I know that you as a university or you as an institution are doing that. You don't suddenly go from crawling to running in a day, but there's lots of steps that help. I'll come to you.
Thanks. Yes, one of the things we had recently at a forum where we got a number of people talking about trusted research environments, and one of the things that came out of that was that there's actually different use cases and different needs, and sometimes one system won't fit all those needs. Some systems are great for a limited set of tools in a very closed environment, which the researchers need to do their statistical analysis. Wonderful. But then there's a group of researchers that actually want to do advanced AI analysis over a whole range of different data assets. That environment would not allow for that. So realizing that there's different needs and different in research environments can be can be quite helpful. Also makes the the question more complicated and convoluted. In the spirit of Reese's comment, yes, let's try and pick off the bits we can. But I think there's also probably other environments you need, or combinations of environments. And coming back to Katie's point, yes, I think at some point you need to collect, as researchers start their project or start to embark on their project, an understanding of what they're going to be doing and what they need for that. And that might be a certain type of environment, or maybe a different type of environment, depending on the sensitivity of their data, and also depending on what they need in the way of tools to run over that data. So, yeah, I think basically what I'm trying to say is I think the landscape is even more complicated and a bit more fuzzy, but doesn't mean to say we should not start working on bits of the landscape. So
I'll loop us back to users. So Yvette's question. I think one of the things that we found useful with Rakaora was having a sandbox environment for researchers to develop their workflows and have test data that wasn't sensitive, so everything could execute in the environment they would be working in, to then, before moving it into the actual secure environment and running on the real sensitive data. So having that kind of test environment and that formed part of our onboarding process for workflows.
Cool. I just follow that up. We see that in microscopy. They really want users to train up on what they're going to do on something that isn't a $10 million microscope. And you could look at it the same way. This is actually expensive, complex, has to be run properly. We need this sandbox idea is a really, really good idea.
Okay, so it's been interesting hearing the infrastructure sort of view and the user's view. I'm just looking at that elephant that's still in the room. So as a new an institute that thinks it's going to get into this space, what's the kind of dollars you're looking at? I mean, I know it's a dangerous question, but it kind of helps us when we're thinking about how far do we go with this and what sorts of things can we afford to put in place. Can anybody?
I don't remember the exact numbers for the SERP environment, but I know that they told us that for every institute that they support, they hire 2 staff, full-time staff, and they help the institute to set it up. They manage it for them and with them. So 2 FTE, I don't know, Mark, do you remember the number better?
I do, but unfortunately it's commercially sensitive.
Okay. Okay.
This is a trusted environment.
Yeah.
I think, I think in terms of setting something like this up, I think there's a couple of things that I would point out. I'll give you Mike in a sec. One is the use cases that you're trying to build, the security frameworks that you're trying to adhere to, and exactly whether you're conforming or you're actually going through certification processes makes a big difference. I'm pretty sure Claire can attest to that one fairly strongly. And also what infrastructure you currently have that you could use. We're going through a process in the pilot at the moment of working out what that means and what that costs. So we're still trying to answer that question, and we're trying to answer it in a on-prem environment, as well as what does it mean in a public cloud in terms of OPEX costing, and what does that mean for an institute in terms of how we support that.
I think to give you perhaps a little bit more of an answer, we know that it's going to take at least those 3 people over there to run this environment. We're looking at 2 environments at the moment because, as someone pointed out, the needs are quite different sometimes, and sometimes you might need something that runs on-prem, sometimes you might not. The important variable, though, is what's the denominator? How many of these do you need? How many externally funded projects do you have that might provide overheads for this? And in our case, it's in the hundreds.
Yeah,
So
I guess
that
there's
makes
a question,
a big difference.
And I have the same issue around, should we have a national data archive rather than all trying to muck around with trying to archive and stuff or not? Is this the sort of thing you should have a national TRE service capability rather than all the institutions doing it?
And that might depend on the level of... Carol mentioned right at the beginning of her talk
there's different levels of TRE. So you have small groups, so that might be something you run more institutionally, then you might have stuff that's institutional, then you might have stuff that's national, and then international. And I think that speaks to what you're talking to. I think we're going to have to wrap up. We can continue the conversation at afternoon tea and afterwards. I would be really interested in anyone who was who wanted to continue the conversation online throughout the year. So send me an email. Do you want something to do with infrastructure training? So y.wharton, W-H-A-R-T-O-N, at auckland.ac.nz. And yeah, I'd be really keen to know if people wanted to kind of form a group that got together and discussed these things.
There's also an RDA working group on trees, if people are interested.
Just following up on your people talking to you about stuff. This is something we actually talked about after last year's meeting, is that this is an event where we come together kind of once a year and have these discussions. And I think it would be really good if these discussions could seed ongoing discussions throughout the year. So if you were able to have some, semi-regular online sessions to continue the discussions, it would mean that next year when we roll into these birds of a feather sessions, we actually remember what we talked about last year. We've been continuing the conversation through the year, so I think it's a fantastic idea. So let's try and do it.
Hello. Thank you for staying until the last session. My name's Jun, Product Manager at Nessie. I'm here today with Kahu, who's our DevOps support specialist. That's what it says, but the actual title's a lot longer. We've been debating about
We'll just keep adding words in front of it.
Yeah, we'll talk about Nessie's Research Developer Cloud, our new offering, relatively. It's a cloud-native platform enabling challenging solutions. So what is Research Developer Cloud? It's to help empower research software engineers, and it's somewhere where you can build custom research tools, and it's an infrastructure as a service. So what does infrastructure as a service mean? I had to Google around for official definition, and I kind of mixed a couple of results and put it there. But traditional Nessie HPC facility, if we look at it as a very specialized kit, wood-fired oven where you have to queue up and use it, take turns. Our new cloud offering is more like a mini kitchen that we offer to each tenant, so you can do whatever you want there, make a mess, but not impact other mini kitchens. So we're trying to come up with good metaphors, but we're in the process. So queue-based versus interactive or long-running or other types. So we launched last September, starting with what we call essential basic building blocks. So these are ability to launch compute and select from images and storage, network, identity, and so on. All of those accessible through OpenStack API. And let's see, this is what the dashboard looked like. But we really are encouraging our users to interact with our cloud through code. So we use the term infrastructure as code. So if we stick to that kitchen cooking metaphor, if we develop or configure a tool directly on a VM, it might be just like cooking, but infrastructure as code is kind of more like writing a recipe. So Kahu will later show some examples of Terraform and Ansible, which are some of the technology that looks at those recipe, the code, and automatically deploys the environment, recreates the whole thing. So it makes everything transparent, repeatable, and easier to collaborate, and so on. So how do we differ from other cloud providers? So we are really focusing on good developer experience, and we have noticed there might be some gaps in sort of DevOps capacity. So we want to collaborate. We want to bring our DevOps specialists to work closely together with science leaders, and then build shared knowledge and expertise. And then those shared knowledge might become what we call blueprints and patterns that are combinations of perhaps GitHub code base with instructions and so on. Also, there's an advantage of us being adjacent to existing NESI services such as consultancy, HPC, and training, and so on. So we want to highlight the DevOps. We want to promote a great developer experience by collaborating with you and applying good DevOps practices. So what it does is these are a set of practices to enable collaboration, visibility, rapid development, and deployment cycle, and makes it shareable with wider communities and so on. I'm just looking at time, but I can go into some examples. So, so as an example, in the phase of code, we might encourage use of tools such as GitHub, GitLab for source control and collaborative development. And as you go around, GitHub Actions is something that can be triggered automatically upon committing new code base, and then it runs automated tests, and if it passes, it will release and deploy. And at the operate phase, we are using technologies such as Kubernetes to help monitor activities and scale and feed that back into the design and back to planning and so on. And we want to apply secure measures in all steps, and thanks to Michael Carrot, who has been helping us throughout all the steps and design of the underlying architecture to do so. I'll cover some of the existing tenants as well as some of our early access tenants use cases to sort of draw a picture of what kind of projects are suitable for our environment. So the first one is actually our long-running partner, Aotearoa Genomic Data Repository. So this is a use case where we want to host a data repository with that is onshore, and we wanted a platform that's sort of running all the time. So it's a long-running example, and we connect together with other technologies such as Google Forms and Zendesk for some of the processes. Here's a screenshot of our data repository, and we have over 4,777 files and more coming. And I'll talk through 3 of our early access tenants who have recently joined to test out the environment last December-ish. So one of the first one is Oakman project. We haven't started building anything with them, but their use case is very interesting. So they are machine learning-based video analysis for early detection of neurological disorders. So clinicians, nurses can take videos of infants and upload it, and they have an existing HPC workflow with us that analyzes those. But what they want to use is add cloud pod backend where mobile apps can transfer and upload the videos and host. And once it reaches critical mass, then it gets piped into the machine learning part. And the next one is we're working with Christoph Muller's group from GNS. This is more of AI, again, machine learning research around rapid characterization of earthquakes and tsunami. And for this one, their group has their RSC, Karen King, who is actually really well versed in DevOps. So Kau and Karen has been working together to deploy Kubeflow, and they've set up a GNS container so that I'm having trouble describing what exactly those two does, but they set those up so that they can take their workflow to the next stage. And the other one here is Manaki Whenua Land Care Research, which I also mentioned in my other talk. So we're starting with deployment of LUMAS model building pipeline. So LUMAS is land use management support system, and so far our NESI's Chris and Kahu has built a test pipeline, and they'll be going into testing out the building process with Alex Hartzik from Manaki Whenua very soon. And Nick Spencer here approached us with a vision of starting small, but eventually leading towards a cultural and paradigmatic shift in the organization, so that all of these tools built kind of become exemplar on being more transparent and shared across the organization. And here's a screenshot of LUMAS from their GitHub. And I'll pass on to Kahu, who will talk about our training environment.
Thank you very much, John. It's not quite like Zoom, is it, when you're all looking at me? Sorry, we'll get used to it. So NESI's training environment was one of the things that we chose as being our own client on our own product, allowing us to actually test and use the different things that we want to do. And by picking the training environment, it also gave us a use case to be able to possibly offer that outside of just the standard confinements that we have at NESI in the training. And so we used the ML 101 and ML 102 as our kind of base thing to start that on. As John said before, we're using Terraform, OpenStack, Ansible. Now, Terraform is just they use for orchestration, and Ansible's there for the configuration. So Terraform allows you to go, I want X number of resource, VM, virtual machine, and then Ansible goes, I want to deploy Apache to that. Basic, real low-level access to them. And it's all deployed on OpenStack, hosted as Git repos, so that then you can share them with everyone, and everyone can have a play. Real basic, repo, fire off a GitHub action, we deploy the training environment. Now we've got 2 web nodes, or 2 VMs that run there. The services node being like an LDAP kind of system that has Keycloak on top of that. The web node is the open on demand front point. Now you've seen Thomas's talk about it, and there was also another talk by the HPC Now gentleman around open on demand. And so in front of that, we actually have a Keycloak instance showing that you can use single sign-on when you need to for those particular things. And also because this is a dynamic environment, you also need to be able to access it through a URL rather than an IP. Some of us can remember IPs, but most of us will not remember IPs. So we use Route 53 DNS from Azure. We write that there, the web node and everything is spun up, and then during the creation of all of those, we use Let's Encrypt to make sure that there is HTTPS encryption across the whole thing. And then to the side of that, should you want to use a bit more power, we also deploy a Kubernetes cluster. And that allows them to have multiple users running on this system. So where are we now? We have a basic training environment set up that is reproducible with Ansible and Terraform. Both Chris and myself have created, destroyed, and created this multiple times, sometimes using a few more resources than we needed at the time, but we've been able to get through that. They're all based off ML 101 and 102, and we recently in November, ran a ML 102 workshop on this training environment, and the feedback that we got was there was no logon issues. Everyone was in straight away within 1 minute. No one had to sort out their logon and anything like that. Where do we want to go? Well, we want to get to the point where when we do deploy the training environment, they get their own domains, things. So you want to be able to run ML 101 in Auckland, ML 101 in Christchurch, all at the same time. And then also the ability to self-provision these environments, rather than coming to see John or Kahu going, hey, I would like an environment, being able to submit a JSM ticket, going, I would like an ML 101 environment with 20 users. Off we go. So part of the developer experience as well is sharing what we've learned as well with everyone else. Now, very, very basic example of using Terraform on our OpenStack RDC. Now, I know a lot of people have known about HashiCorp's change in licensing when it comes to Terraform. You can use OpenTofu They're essentially the same kind of things. You can use, I believe the other one is Bloomy, it's another one that I've heard around. But you can also use the general API should you want to deploy it. But generally, Terraform is an industry use. Everyone knows it. It's used quite frequently. So we've got a very basic example of just creating an instance and then destroying that instance afterwards, all within the space of 2 minutes. Continuing on from our basic one, we also have the training environment that is actually available as well within our Git repos. It's all there, and that is a screenshot from that running environment. You can see we've got the ML pinned at. We've all seen the open on demand one there, ML 102, and then we also have an example one of ML 102 being deployed to a Kubernetes cluster. It's taking that pod, deploys it inside of their user's name. So in this case, the user is train2. It deploys it within that namespace inside of Kubernetes. We won't go too much into that because that's another kettle of worms when it comes to Kubernetes. Now, the Kubernetes stuff is based off Cluster API. Again, we have more examples that we are going to share with everyone to play with and destroy. All of these are workable on any OpenStack-based system. So it's Catalyst Cloud, Nectar, all following the same thing. You just need to change the auth points or what you're using it, and it's all based on the clouds.yaml file. But we have a Bootstrap management cluster, which is it's a whole chicken and egg scenario. To run Cluster API with Kubernetes, you need to have a Kubernetes cluster. But how do I get the Kubernetes cluster without a Kubernetes cluster? So, the Bootstrap management cluster does exactly that. It basically just spins up a small VM, creates a Kubernetes cluster on that using kind, then, using Cluster API, generates a cluster and offloads the whole management workload onto that cluster, removing the kind VM at the end. So you're only left with a management cluster. The one below that is what you would use should you want to then continually deploy workload clusters to the environment. And it just goes, I want a cluster named Kahu's Test Cluster. I want 2 kind of control planes with 4 worker nodes, send it off to the management cluster, and off it flies. We have also just started to use the GPUs in that one as well, so that's still in a bit of a test phase, but we have got the Kubernetes pods working with GPUs at this point too. So that's the next part for ML 102, is to start using those GPUs inside of the Kubernetes cluster. Back to you, Joe.
Cool, thank you, Kyle. So we will be in the near future, so what we want to do is turn what he just showed, all of these into a bit of a wrapping around it so that we turn it into a blueprint so you can have a look and read and deploy it in a same OpenStack environment or our OpenStack environment. And what we want to really help is create a pathway for RSCs so that they build the tool for their group immediate needs, but we want to make sure it can be, the knowledge can be shared to their organization and eventually wider communities and sector as a whole, and sort of inspire others to contribute as well, and so on. So we want to do that through using good DevOps practices, using those open standards, and so on. And we are also learning from various other organizations, and we recently also had a chat with Arcos, who is also doing something similar to Blueprints, at a different level. So if you think your project can benefit from working together with us, we invite you to our early access. You can apply and read more about the Research Developer Cloud at the URL there. And we are also constantly pushing out updates, so please keep an eye out and feel free to reach out to us at support@cloud, but also my email address, which isn't there, but it's jun.huh@nessie.org.nz. Thank you.
Tēnā koutou, thank you for staying for the final session. Here's your last call of if you want to go to Jana's session next door and talk about women in HPC. And if you actually just want to leave, we won't know. We'll just assume you're going next door. But to those remaining, thank you. Final session. So Reese, Nick and myself will be, facilitating a BOF I guess really continuing from our data conversations that have happened over the last 3 days and giving a slightly different view from maybe the BOF we ran yesterday, talking about numbers. We've got some numbers that could be wrong, but hopefully we can stimulate some really interesting conversation and talk about the journey that you've all contributed to getting these numbers and what next steps might look like. So for I guess a few new faces in the room, so we'll start with a little bit of context. So we'll hand over to Rhys for the Australian view, and then we'll move on to what we've been doing over the last 12 months or so in New Zealand, and then we'll open the floor for discussion. So thank you, Rhys.
So about, 10 or 15 years ago, Australian unis started to install data services to help researchers deal with data, which before then was a researcher problem. And then when they looked at those services, what that meant was the actual data problem finally became visible to the IT functions of the university, whereas before data was something researchers did in the back room, under the desk or on their desktop or whatever. And then when that became visible, the growth rate became visible. And the question was, can we even afford this stuff? So the actual growth rate Monash measured from the 10 years leading up to 2016 was 75% every year. That is a growth rate that requires your IT budget to rise every year by 30% on data endlessly, and is not possible. So they engaged their researchers in that discussion. They discovered talking to researchers they could get it down to 40%, and that's just about viable. Just by asking them, well, what are you storing, and do we need to have it on hot disk, and can it be on tape, and do you mind? And they say, well, provided you don't lose it, we don't actually care where it is. We don't even know what it is anymore. But if you don't, we don't want it lost, right? And so because of that, Steve Quinnett at Monash asked me to have a discussion with the other unis around the country saying, do you also have this problem? And if you do you want to work on it together? And the answer from the big 5 unis was yes. So we set up a thing called the Research Data Culture Conversation to talk about data. And the whole idea was just to talk about it. What's the problem? So the group was founded on the IT sections of the universities or the eResearch components providing data services, and reached out to include the library and the research office and the CIO if they weren't involved directly, and so on. And we ran workshops and all kinds of things. And the rule was, if you don't feel the pain, please leave the room. Because we actually want to talk about what to do about the problem of growing data fast. So that's the universities who are involved, and they're some of the people who drove the core team, if you like. And the summary we come up to this is, institutions, unfortunately for them, are where data ambitions and obligations meet budgets. So researchers can have all kinds of ideas in what they're going to do with data, but someone has to pay for it. And it turns out it's all in the institutions. Most of the research data in the sector is inside the institutions in the sector. And the poor institutions, of course, don't know much about disciplines, really, when you think about it. They hire professors and say, you know about disciplines, tell us. And so they have a problem. They need discipline-centric responses to be defined for them, so that, because each university can't separately decide what each discipline should have. And that's a foundational problem in the data system that we've got. And instead of that beautiful world at the top, coherent, discipline-sensitive responses defined, our institutions are facing an uncontrolled expansion of the indefinite retention of uncurated digital content. And we set out to measure it. And we did measure it. Now, there's some good reasons why you should care about it, and they're on the slides. So we have really good data from these institutions because they spent a fair bit of time on this, and it wasn't simple to do. I've looked through endless spreadsheets on data stores and backup systems and cost functions, and we actually hoped at the start that we could come up with $1 per terabyte number over time so we could see what was happening. It's just virtually impossible to standardise across all of the different funding arrangements and structures and implementations. And this CapEx was actually used for OpEx, but we looked the other way, and this OpEx was used for CapEx, and we decided not to tell anybody. And it's just, look into these spreadsheets, and it's just horrible. We actually gave up trying to standardise a cost. Not because we didn't want to, it's just way too complicated to standardise a cost. So that's the kind of growth rate. And the curation standard is, if a researcher doesn't delete it, keep it. If we keep it forever. Whether we know where it is, that's a different question. And that is what the curation standard is of that data. Except then we discovered that it's not data. But at the moment we're talking about data, right? That's the growth rate in data. And the universities, we used to have these meetings and they'd say, we're going to be swamped by cryo-EM data next year, there's a tsunami coming, and then we'd come back together in a year's time and look at the numbers and say it didn't happen, but it will next year. For 7 years we've had that discussion. We're about to be swamped by data, and every time we measure it, it turns out to be that growth rate. There is actually something that suppresses the growth rate of data, and we think it's labour. The labour cost of understanding and using data is not zero. And researchers we only have so many researchers, and there's only so much data they can eat. It's just not possible to have infinite data, which is why Carol's talk is so dangerous, that we could use AI to look at the data and we just look at the answers, right? So then, on my own volition, I decided, what if we asked everybody how much data they got and added it up? This is what this BOF is about. For the very first time, probably anywhere in the world, we attempted to find out how much research data actually existed in the Australian research sector. And the way we did that was myself and Eileen Sue from Monash University got in touch with everyone I knew. Directly, the data managers in about 85 different institutions, and said, would you like to help us work out how much data there is in Australia? And they all said, absolutely, what a bloody good idea. And so the questions were, what's the first copy of the unique data that you've got under institutional management for future access? We're not looking for data under desks at this point. We're saying, of the data the institution is managing for future access, how much is there? So we had all these Zoom, thank God for Zoom, right? We had all these Zoom meetings where we talked in an hour explaining what we're trying to do. We set up subsequent meetings, and there's 85 institutions, there's a lot of meetings. And 3 or 4 weeks later, they all came back and said, we don't know. We actually have to do real work to answer that question. There's no existing, well, most of them said, there's no existing report on data as an asset managed by my institution. And of course, some of the medical research institutes came back and said, well, we're not even sure it's data. And that's a bit of a problem, because if it is data, it's human data. If it's human data, we bloody well better know we've got it. And we don't. Can you please not report our numbers? Seriously, we had MRIs say, we have to fix this. And the particular ones in question have hired people and have got programs running to be able to answer the question, what is it that they're keeping? And how much of it is actually human data, and that it is under control. I don't think any of our institutions could take a file and tell you which ethics approval applies to that file. You're laughing. And yet you'd think you could, wouldn't you? What is the point of the ethics approval? But after the ethics approval exists, control is released. There is no control after that point in the way we operate our data management systems at the moment. So they were the questions we asked. Hardly anyone could answer any of them. We wanted 3 data points. No one could go backwards in time, so we gave up. Well, just so you know, these are the organisations that responded. It proved impossible to answer these questions because research data assets are not identified within the broader corpus of digital content. We keep anything a researcher won't delete, whatever it is. And internal reporting on research data volumes and properties basically didn't exist. Now, interestingly enough, everyone, and some of the people who are in the room here, did a fair amount of work to actually deal with that. So we relaxed the constraints. What's the first copy? So we don't want replications in the count. We want original copies. What's the first copy of the digital content that you're managing for future access? What's the total storage volume in use? Interestingly enough, not everyone could answer that question. How much of your digital content is served as openly discoverable? Now, we had originally open access, but it turns out hardly any of the data that's described as open access is actually openly accessible. It's almost all filtered by an access protocol to which the answer is typically no. So we went with openly discoverable. That's the minimum standard. How much of your data do you publish the existence of? So in Monash University's case, it's 0.03%. I think in UNSW's case, it's 0.1%. These are very low numbers. But we weren't able to ascertain how much of the institution's data was in the global repositories. Because in fact, because we contacted the because it became obvious that's where it is, right? It's not in the institutional repository because it's been pushed off to some global repository. They don't know. EMBL, I was told from EGA, because I have good relations there, the Australian EMBL node would have to ask EMBL whether they were prepared to find out how much of the data they were holding came from Australia, because they don't know. We asked Amazon and Azure of the data sets they're holding for public access, how much came from Australia, and they said, well, we can give you a list of them all, but you'll have to go through and find out. We don't know. So this whole question hasn't really been asked before. Where is your data published? So we asked that, how much is openly discoverable through services you operate? And how much of it is suitable for sensitive data? Well, gosh, they're the numbers. We did it twice. The second time around, everyone said, do we really have to do this again? This is actually hard work. And, you know, Rene's sitting there smiling. He's implemented systems to make this possible now. And that's what's going on. Some systems are being tested and deployed that will be able to answer this question. So the answer was, in December 2021, by our best guess, now we're approximating here, right? We had answers from about 70% of the total research intensity of Australia, and we just multiplied by the relevant number to 100%. Most of the small unis simply could not answer any of the questions. And we had those meetings and they came back and said, we cannot contribute to this survey because we cannot answer these questions. Anyway, so we extrapolated slightly. Of course, CSIRO didn't extrapolate for. They told us the real numbers, and it took several months to get them, but we got the actual numbers. For the MRIs in universities, it was extrapolated. For all of the national research infrastructures, and we contacted them all directly, we have absolute numbers. However, we discovered some really interesting things. The microscopy and imaging investments in infrastructure could not tell us how much data they created and sent to universities every year. And when we queried that, the capabilities themselves had tried to do that for several years, and it was not possible to get an answer to that question. And it's really curious, isn't it? Because we were interested in how much data is injected and how much gets to the archive. Is that the reason the growth rate's only 30%? It's falling off the desk. But we couldn't get a number on the injection rate of data into the system from the people generating the data because they don't record it. That's very curious. Anyway, 300 petabytes, a year later, 370 petabytes. If you extrapolate that today, it'll be 450, growing at a rate that doubles every year. And the question is, how much of that is actually data? And we don't know. So what's happening now is we're having a discussion with CAUDIT, the Association of IT Directors, about how this could be done more systematically, if we want to do it systematically. CAUDIT have said to us, we might measure, but we don't know what to measure. How on earth will we know what to measure? Because we daren't say what's important in research. So what will we measure? And we've got the 5 academies in Australia in a group who are prepared to be the research advisory group to CAUDIT to answer the question, what should we measure, which is pretty good. So we're hoping that will run this year, and in the future we'll have a record of what the data state is. And the question for us will then become, well, what would we like to know? What should a steward of data care about? What should a steward of data, because we are all stewards of research data, as a steward of research data, what would we like to know about the data we're the steward of? Right now, we do not know the answer to that question, which is really interesting as researchers to think about, isn't it? That might be the end of me. So then, of course, for our friends in New Zealand, we said, why don't you do that too?
Thanks, Rhys. And so we did. Thanks largely to the people in this room and a few others. We borrowed the methodology and asked everyone the same 4 questions so we could compare to our Australian counterparts. And so as of December 2022, we believe we had 45 petabytes of digital content associated with research within New Zealand. We additionally asked the sort of those other nuanced questions and similarly got answers within error bars that look like this and answers that look like this. So the nuance on this is not particularly granular, but I think we get the similar picture of we can't quite work out how to exactly answer these questions, again, because no one's ever answered them before. And we, I guess, scaling down, not 85 institutes, 16 institutes, 14 were very happy to have the conversation with us and engaged and wanted to answer the question, and 12 contributed to this round. So we've got a reasonable representation from the sector in terms of kind of as good at accuracy as we can get, and then a little bit of extrapolation there. And then finally on this, we asked a 5th question in terms of Maori data governance, what data governance was in place over relevant data, and no one could answer that question. So I think that's sort of the context of the baseline where we are now. We asked this question again to try and do a similar, model with Australia and look at our growth rate. I asked over Christmas time, so I don't begrudge anyone not getting back to me. And I think, to echo Rhys's comments from Australia, it was hard to do the first time, and then we've forgotten how to do it, and we had to do it manually, and then it's still really hard to do the second time. So we've got, from a subset of thank you to the institutes who did provide numbers, we've got a much larger extrapolation this time because we've got fewer data points, and we get a 25% growth rate, which is going to be wrong, but it's at least, consistent with Australia, and perhaps doesn't show the data tsunami, because I don't think anyone's actually yet seen that within their infrastructure. So I think, and I'm going to call on institutes to kind of have a bit of a discussion about how they found it from their perspective. But I think I'll open the floor with this slide and this thought. Is what we're keeping, is what we're measuring, is it data? Is it research data? Is it valuable? Is it precious? Can it be reused? Or is it research debris?
It's a funny word, debris, isn't it? Everyone believes if you build a building, you're going to have builder's debris. So research must produce research debris, mustn't it? By definition. And if researchers don't delete it, we're going to keep it forever. What we don't know is how much of it is there. But Cyro might know.
I'm not sure that we do. We certainly know how much data is on the system, but as far as debris goes, it's really hard to tell. And part of that comes back to not having the, governance or the systems that allow us to capture that governance, so that we can actually flag which data as it goes through our systems actually falls out as debris. So we would consider data in a scratch file system to be debris as opposed to actual data. I'm assuming that there would be data in there, but that data should be transferred then onto something else, right? That holds the actual output for a longer time. So, because they know that they can lose stuff that's on a scratch system. So we can infer it to a degree, and I think if we had better guidance and were able to coach our users a little bit better and they followed that guidance that created scratch folders, even if it's not a scratch file system, that would tell system administrators that, well, there's a good chance that that can go. We've found that in our archiving side, we've found a lot of folders in our infrastructure that are called archive, and surprise, surprise, when you talk to the researcher, they're like, well, we really want to keep that stuff, but we don't have anywhere else to go with it. So it's like, okay, well, then that's probably something that's good for an archive. So let's fill that gap and create that. I think the data tsunami story is a really interesting one. I don't think our infrastructures are collectively capable of storing it, so the researchers have a tendency to not create it. Like if we look at some of the radio telescope equipment, we know that it can generate a significant amount of data, and we have enough infrastructure to store about 2% of it. So we tell them up front, you choose which 2% and we'll keep it. So the potential tsunami is there, but it's only going to happen if we give them enough storage to consume, because they'll find a way of consuming it. And it'll just make our problem bigger, and we just kick this can down the road, you know.
I think just to note on that, we excluded scratch systems. So in theory, this should be research data, because we didn't include any scratch systems in the count.
Hi, so I'm new in CRIs, but I've been doing data science in public service for a really long time. And this question keeps coming up of why on earth do you need to keep making more stuff in the shared drive? And I keep having to explain to IT people that public data made with public money, you're not allowed to throw it away. I'm not allowed to determine something as debris in a publicly funded organisation. We nearly have permission from the government to throw things away, but not quite. So we have to keep everything until we get legal permission to throw it away. So it's very difficult for us to manage this debris.
If you have to keep it, should you know what it is?
Oh yeah, we should, yes.
Looking at the graph kind of makes me ask a question. We talk about data, we talk about debris. Do we actually really want to think about data I know nothing about, data that's well described and reusable? So do we want to actually kind of shift the conversation? I know it's hard to measure, but is that where we actually want to get to? Because some of that debris is possibly just data we have yet to understand is well described. And what mechanisms can we use to help us make sure that what is the data that is in those storage systems is better described in a more automated way? Are there things we can do to make life better?
Okay, so I ran a project for the last 3 years, which was an investment theme in Australia, that went to mainly universities, but also increased capabilities, with a set of metadata, and said, can you report on this, on your data holdings? Thinking that, it wouldn't be a large amount of organizations that would be able to do this, but I was actually surprised at how few could. And that tended to reframe the way I engaged with them. But one of the most difficult conversations you had was, if you can't tell me who created this, where it was created, how it was created, who's responsible for it, even how big it is, where it originated from and how long you have to keep it for, why on earth are you still keeping it? Why are you creating this problem for yourself? And it seemed to my mind, seemed to come down to an authority to delete is not well defined and not actually accepted by anyone. The fallback on legislation, I think, is not helpful, but at the same time, I think there's quite a large space to make a stand and say, actually, well, we believe this is the case, And instead of thinking about what we're allowed to do, think about how legislation can enable us to do what we need to do.
Now, we've got to remember, we're not here to solve the problem. I all want to solve the problem. It's not necessarily a solvable problem. But do we want to shut our eyes and not know anymore is the real question, or do we want to keep knowing? Do we want to understand the data we're keeping, or do we want to not understand the data we're keeping? Because this can stop happening. We can not bother to measure. Now, as I said earlier in the week, I've learned more in the last 2 years about data than the previous 20 because we measured. And the depth of questions you get to people you're talking to in the institutions is fantastic. But the challenge is actually hard. And part of the problem is these are actually files, not research data objects that we're looking at. We haven't encapsulated our data in a RO crate, would be the current idea. And we look at a file, and looking at a file tells you very little. Very, very little about that file. Our file systems are not data management systems. And that's where all this problem is coming from. But wouldn't we like to know whether it's a 10% of that is actual data or 90%? It's possibly quite small. You know, you can keep every run of a debugging piece of software forever. It's not really useful, is it? It is debris. If you do an analysis using the wrong technique and your statistician friend says, your data's not a normal distribution, that doesn't work, well, you should throw the calculations away, but instead you just leave them in that folder and start a new folder and do it again, and we keep that forever. This is what's in there. Sorry. So the question isn't how do we solve this problem, the question is do we want to know?
So what about obsolete file types that we shouldn't be bothered keeping on our systems anymore? Are there any recommendations about things that we should just chuck out?
We're not trying to solve the problem, we're trying to understand it.
Is that part of the problem?
So just explain that a bit more. What do you mean by obsolete?
Well, where there is no software program that anyone has that can open it anymore, and yet you've got the files on your storage systems.
So I have a work archive that has every file I've ever created back to 1986. I know what debris is. So I do. If I try to open a PowerPoint from 1986 on Microsoft on my desktop, it won't open. On Microsoft 365, it still won't open. Turns out on Google Docs it will. Isn't that unbelievable? Isn't that completely unbelievable? Anyway, sorry. It's, well, way less than 400 gigabytes.
So many things to say. So we were part of this, and it kind of prompted us to start looking in a bit more detail of what we've got. We've only really started this journey, but I did actually. So our researchers are supposed to store data on SharePoint, right? Don't comment on why, right? Partly because that's where we can do records management from. It's a lot easier in SharePoint than in other places. So when I gave the numbers, I gave this very large number, and then I thought, I wonder what it truly is. So I actually did an analysis and pulled out all the file extensions and then analysed the file extensions to work out which ones were research data. It wasn't so hard to do, actually, because we work in a certain domains where there's only a certain number, and actually there's quite a common set of file extensions. So that actually brought down, when I did the analysis, that meant the amount of research data on SharePoint was only 15% of the number I'd given, right, because we also use it for corporate. So that's interesting. I'd like to try and repeat the same exercise on our isolons, where I think it will probably turn around that we've kind of got 15% of other stuff and mostly data. But what hasn't been included here, and what we asked in a survey we did of our researchers last year, was where else do you put data? Right, and so 14% of our researchers store their data on Dropbox, Google Drive. There is a very large number that are using OneDrive, which they're not supposed to use it for. But then also 22% are just storing their data on external hard drives and USB flash drives. Right, so when you're doing these counts, you're only sort of getting one view of it, and there's how much other data we've got floating around in these more potentially risky storage. Yeah, so there's more to the story here. And if nobody's got anything else to do, they can keep diving into this because it's really interesting.
There are two views that I place over this problem as far as why we should be interested. My background is in research, and so research integrity plays a very large part in my view of deciding what we should keep and what we don't necessarily need to keep. Now that's quite a loose term. To my mind, most people here would probably be much more inclined to think about, well, when this hits my bottom line, that's when I'm going to be interested. And while the growth rate is as it is, and I think you mentioned yesterday, Rhys, that your calculations had it on the border of technology unit costs, there's a group of us that believe that those are going to continue to flatline. And so actually it's going to hit bottom lines probably quite quickly. Maybe the tsunami is not the data. Maybe the tsunami is driven by the technology that's unable to store the data that's growing at a relatively steady rate. Either way, you need to be able to understand what you have if you want to either reduce your risk, where stuff is, and its exposure, your risk appetite. But I will always return to research integrity. Debris is not useful, and data are.
One of the things that, listening to what people are saying, that it made me think about was the fact that yesterday, I think it was yesterday, David was talking about the studies that they've done in UNSW and the different definitions of research data that have come out of this. And I wonder if we're doing some counting of this, if we should have an agreed definition of what it is we're counting, even if we can't quite, if we're just counting what's in a file system, or are we actually trying to delve deeper and try and decipher what is research data and what is something else. One of the things at Auckland, we have so many different types of research that goes on that it is very hard to say this particular file type is not research data. So it just got me thinking, is there something we could do to agree on to make what we're doing a little bit more oomphy in terms of the integrity?
Rhys, I think the answer to your question is yes, it's better to know than have your head buried in the sand. And I think there's a whole lot of different motivators and drivers, compliance, risk management, but for me, the most eye-opening stat that you seem to have found is that amount of openly accessible data. And I feel that often that what's overlooked is, in this increasingly metricized age, if you can't measure it, the value isn't there. From an institutional point of view, there's a huge amount of lost value in terms of what can be measured in these research data assets. So whether it's some kind of link through a persistent identifier to a research repository, even if that data is put elsewhere, there's a real, I think, opportunity for institutions to support publishing data and seeing where it's been cited and seeing how it's been used, because data is a very useful and reusable asset. The publication that your academics publish is also very useful, but it tends to be limited in a certain sense, because it's got an interpretive layer and it's got data can be used for replication, for integrity, for informing other research projects. And I think more awareness at those senior leadership levels around what's an opportunity that we're missing, what value can we capture. We want to have an international research reputation. Maybe you've already got it and you just don't realise it because your researchers are putting it in Zenodo and OSF and whatever, and not your institutional repository.
I'd agree with that. And if you look at the first set of questions, I feel so naive. Let's just ring up everyone and ask them how much unique data are you storing for future access, and they'll tell us. They don't even know what it means. You know, we were so naive, but that's what we believe. And the reality of what we're actually keeping is different. And to me, we need to understand that gap. We thought people would know how much of their data was published, but of course, when a researcher uploads a file to EGA, no one in the uni knows anything. And of course they don't delete it. So it's stored here as well as there. But there's no record keeping of what's been uploaded to EGA by anyone, even EGA. So there's a whole missing set of things we could know, that's all. And I just feel we just asked the immediately obvious questions everyone would have thought could be answered, and none of them could be answered. And that's what we learnt by trying.
So, I just spent an idle moment looking at a file, a directory on my computer called research data, which is research data that I've created or played a part in. And I asked myself the question, why do I still have that data? And I think there are 3 reasons. But my point is, what I think would be useful in this conversation now is to ask researchers, why do they keep the data that they keep? Because I'm not sure that we've heard that voice yet. The answers for me are, A, that's an interesting data set still. I don't even know if anyone else in the world has a copy of that. B, I remember doing that. I really enjoyed it. I'm keeping that data. C, this is data where I published that study and it's the working models for all of that. And I never really passed them all out and figured out which ones I needed to keep. But I know I'm obliged to keep at least some of them. Maybe all of them, I'm not really clear. So for me, there are at least 3 reasons why I might keep stuff. And I wonder what we could do to assuage some of those concerns. For example, does better repositories, either at a university or nationally, does that help you have confidence that the data exists and you don't have to be the sole custodian of it forever? Does it help if we have clearer guidelines about what we need to keep, what we need to throw away? Do I need counseling if I'm carrying around data from 25 years ago for an experiment that I really loved? Thanks.
We do have another researcher in the room as well.
So Nick asked me to answer that question, but I think I only have one answer, which is because I haven't had to delete it. There's been no requirement to delete it, and there's been no incentive to delete it. And as far as I'm concerned, there's no cost to having it still there. So status quo. So.
I have a question for Yvette. When you guys rolled out the policy, I noticed that there was a retention and disposal and guidance on how to dispose. When it was rolled out, did you get much feedback from researchers on how they did that or the feelings that they had? Because I'm hearing that it's a lot about the emotions that you have with the files, not so much. I haven't heard the words legal or risk yet. And I was looking up on Google before, and I remember that for legal records, a solicitor only has to retain it for 10 years. And then actually, having worked in the firm, we actually did every year boot out stuff after 10 years because we didn't have to keep it. And for tax purposes, it's 7. So, is it a feeling or is it a requirement? Sorry, that was multiple.
It's probably actually a Laura question more than a me question, but I will answer it from what I know. Our code of conduct prior to the policy had information in it about sort of minimum time periods. So we've always had minimum time periods that you had to keep data. It wasn't always clear. It had words like indefinitely in there, which some people take to mean forever. So some people think indefinitely is not forever. So I think the point of it going into the policy was to firm the wording up and make it a little clearer and maybe remove some of the wording that was a little bit more problematic. So we still have, 6 years from date of publication, 10 years if it's a clinical trial, 21 years if it's related to patent. So there's a series of decision points in there and a few what-ifs. So I think mostly the policy was stuff that was already there. So whether or not we're enacting that properly yet is another question.
Just a question to clarify again. So does that make it clear that the stuff that is published is what's kept, and therefore the working product on the way there doesn't need to be kept, or is it not explicit about how to clean up after yourself?
Sometimes you need all of that working data. If you're going to be honest, you might.
Well, the answer I was hoping for from Mick, he said it before under his breath, was the main reason he doesn't delete it is because of potential opportunity cost. He doesn't want to cut it off, right?
I had this conversation with Anton Angelo, our librarian, data librarian, and on most of those records, on those retention policy, you can keep those for 7 years or whatever number of years, and then you have to check them. And according to him, those dates, those precise dates, were put in place because all those records used to be paper-based, and it used to take room. And the main argument to have those limits was to make room for more paper. And basically, we have the same argument for digital, no? It's not forever, it's not infinite either.
The problem with comparing with record keeping is you are actually well advised to delete records when you can, for legal defence reasons, because of discovery. So if we had a bunch of record managers in here, they'd say, of course you should delete it at the end of, when you get to the disposal schedule, that's what it means, dispose. So it's a different world, and I don't know that we should try and import record keeping principles into research data remembering that research data is a record of what we did as well as a value of what was observed or calculated. So there's two different components to the value. It will lose its record value legally at some point, but it has its continuing research value for as long as it has value to research. Huh? But how's our time going? I want to get back to so if we were keen to keep understanding this, we do have to figure out what it is we're measuring. It's not simple. Just before people say we should keep understanding it, someone has to do some work.
Well, that's actually good because that is my job. My title is data management partner. My job is answering these questions, and I'm sorry I didn't answer your question this time. But because I only just started in September, so I have no idea yet, none whatsoever. But the first thing that I did when I started taking care of all of GNS's research data was I made a very, very large spreadsheet, and I'm trying to identify what things I need to know about each data set. Is it published? Does it have funding to maintain it on this publishing platform, whichever it is, because publishing something online does not mean it is now good for use forever. Yeah, all that stuff. So I'm really hoping that next year I can show up with a bunch of charts that say what GNS does and does not know about its data, because otherwise I'm not sure what I've done with my year, to be honest.
That's wonderful. So we got a yes to shall we keep asking the question, which is great.
Is it a naive supposition that persistent identifiers can help out with this? You know, if you have a data asset that you have the metadata about its funding source, you know, whatever requirements there are, at least moving towards infrastructure, that seems like a nice thing to want to have. And also, is there more of a role, I'm thinking my institution might be different elsewhere, for data curators, so people that don't necessarily have a domain expertise but can look at a data set and say, does it conform to appropriate metadata standards? Yes, this is good to go, it doesn't have nasty sensitive information where it shouldn't, so we can actually leverage the full value of this by making it open in a responsible way, because maybe some researchers, I'm sure Mark would be capable of being his own curator, but maybe there is a, you know, helping sift through the sort of the debris to get the gold and really leverage that, and then have an institution be able to say, yeah, we've got this data and we've got data and debris, and we've also got this amazingly valuable smaller subset of that which we can measure and which is you know, shows the value of the research that we do.
Nick reminded me Melbourne Uni reported 4 billion objects in their data archive. At 1 second each, it's about 155 full-time staff for a year to provide 1 second of curation each. i.e. we're not going to curate at that level. It's just not going to happen.
So one of the conversations we've been having is, what do we do with the past? And how do we improve things for the future? Are we ever actually going to fix the past? Or do we just have to start asking this question and trying to figure out how to incrementally change our future? I think we're coming up to time. Drinks are very close. I sort of made the comment at the end of the session yesterday that part of the challenge is that we're thinking about this from outside the researcher, apart from a couple of researchers in the room who loved their data from 1985. And they love it. Why? Only they know. And so the idea that Mark's going to go back to 1985 and sort of reinvigorate what he was thinking at the time, or that Reese is, and then figure out how to externalise the tacit knowledge that only he holds, and then give it a PID, I think it's a dream state, and I think other people think that too. So if not that, then what are we doing? Because it seems to be clear, and I think Max has made it even clearer, that it's just going to get too expensive and we can't keep doing this. I think Matt Wallace made it very clear. If you guys saw that session, he was very nakedly honest about the problem that he's got at Otago.
So to be a bit more upbeat, we should be extremely proud of the fact that we've done something no other country has done. This hasn't happened before. Now, of course, the truth is that 15 years ago it was impossible because there was no data managed by anybody in any sensible system in our universities. These systems didn't exist. We haven't shown the slide at the end of, went to the International Data Week last year and we put up the slide with the 2 posters we created of these graphs. And the whole room went, is it possible for that? Can you know that? Now, of course, if you're the US, you can't. We're of a scale where you can. But all of Europe, in either Australia or New Zealand, you could get everyone you have to get into a room, and actually say, well, how will we measure this stuff? So we can understand what we're doing in ways other countries actually can't, and maybe we should. But we should be proud we've done it. We were crazy. We saw it through. Well, we did. You could have all said, go away. But everyone we asked said, well, why don't we know? How can we actually say we don't want to know? So anyway, that's the question. Will we keep knowing or will we not? And I think the general sense is, well, someone needs to figure out what that means. But yes, I see a few people nodding. We should keep knowing.
Well, Mick said that if we keep asking the question and that leads to the institution recognising the challenge and asking him to delete data, he will start deleting data. No, you guys, yeah. So, yeah, that's a little promise there that he's made to us.
Just to throw a spanner in the works, maybe. We have a project going on at the Centre for eResearch where we are restoring thrown away data from the 1990s that it turns out was the only collection in the world from a telescope, which is now being used to search for supernova in the southern hemisphere. There are other examples where NASA put millions of remote sensing images in aircraft hangars because they couldn't figure out how to store them. And now they're really important as a record of climate change and land cover and adaptation. So sometimes it's hard to figure out what is debris, and sometimes today's debris is tomorrow's gold. But, yeah.
There's a similar story about journalistic photos being recovered that have a lot of Maori communities represented.
I was going to tell the same story, Mark, and include the fact that they actually had to go hunting through the computer museum to actually find the tape drives that would read it. But include a couple of others to make the point, a similar point. They found a bunch of paper in Green Lane Hospital, which was a study done on a whole bunch of babies, and they then used that data 30 years on and have been doing continuing studies on those babies. I'm one of those babies. So, you know, that was data that was found in a drawer that no one had thought about, and they discovered it and went, oh, wow. So I think there's something in when we're looking at debris, we don't necessarily always just hit delete, boom, gone. We maybe look at it where we find things that might be of value, and we try and do something to help them become something that is described. Doesn't mean to say we do it for everything, but maybe there's something in there in an in-between state.
Yeah, and these are great stories, and part of the challenge, I think, because this question hasn't been asked before, is we don't actually have a maturity of conversation around these sort of views and understandings of what that data might be or what it could be. So I find that really powerful, because research data as an enterprise has been going on for as long as Reese has been investing in it, which is at least 18 years. So these are new conversations, and that's quite amazing. That's wonderful. So thank you all for contributing to the research data culture conversation. We greatly appreciate it. We will definitely be back next year, I think. I think there's enough energy in the room that we'll be back next year, maybe half year, who knows? I mean, we've got a better response for our September question rather than our Christmas question. So I don't know whether there's something in that. Yeah, but kia ora koutou, kia ora tātou. Look forward to having a chat with you out over the drinks. Thanks, Claire. Thanks, Reese.